Assalamualaikum and hi class. I hope that you all fine and stay safe. Alright, so for today, without a further ado, I want to continue my lecture, which is the topic of inverse Laplace transform. Okay, before this you find what is Laplace of ft, and then we get the capital Fs, right? But now you need to find the inverse of Laplace capital Fs. And then you find what is ft. So the objective of this topic is find what is ft. Okay, let us continue. When you find Laplace inverse fs ft, so you can see that Laplace transform will be changed accordingly of their inverse. Okay, for example, given is fs equal to something, and then you refer this fs. Okay, whether this one is the first one is s minus a or not. The answer for Laplace inverse is this one. And then you can check that if the fs is like this, so your answer should be heavy side of t minus a. And then you check fs, whether fs is like this, exponent power of negative as fs, so your answer should be ft minus a, heavy side of t minus a. If your fs is exponent power of negative as, then your answer should be delta t minus a. Okay, and then if your fs is exponent power of negative a as fa, so your answer should be ft delta t minus a. Okay, so you can jot down here, note Laplace inverse fs, you will get ft. Alright, and then depend on the properties. And then one more thing for delta, if fs is constant, so Laplace inverse c, you will get c delta t. Right? Okay, trivia, what is Laplace inverse 1? Okay, this one is Laplace inverse 1. The answer is delta t. Okay, you remember back Laplace delta t is equal to 1. So Laplace inverse 1 is equal to delta t. Okay, you can refer this. Okay, this is the right delta function. So Laplace of delta t is equal to 1 if Laplace inverse 1 is equal to delta t. Okay, let us see example 17. Find the inverse Laplace transform of the followings. Okay, given a is fs, capital Fs is equal to 4 over s square plus 9. Fs is equal to 4 over s square plus 9. Okay, the question asks what is Laplace inverse Fs. Okay, Laplace inverse 4 over s square plus 9. Alright, so from here you need to know what is ft. Okay, how to know what is ft? You need to refer the table of Laplace. Okay, let us look at the table. Okay, this one is the formula given to you. So I will show you how to use this formula given. Alright, so the question is 4 over s square plus 9, right? Okay, so you can check. So the question is 4 over s square plus 9, meaning that 4 over s square plus 3 square. Okay, so this one, no. Alright, so this one. Alright, a over s square plus a square. Okay, so the answer should be sin at. Okay, we go back to our solution. So we can jot down here fs equal to a over s square plus a square. So Laplace inverse Fs should be sine AT. Okay, so from here we know that A is equal to 3. So you can write Laplace inverse 1. Okay, but the question given is 4. You should write 3, right? 3 over S square plus 3 square. So what you can do is you need to multiply with 4 because the given is 4. So 4 over 3. Okay, because you can cancel this. So what you can do is you factorize 4 over 3. So you get 4 over 3. So Laplace inverse 3 over S square plus 3 square. So this one we get 4 over 3. So you know that from here Laplace inverse A over S square plus A square is equal to sine AT. Okay, so your answer here is sine 3t. So 4 over 3 sine 3t. Okay, now we look at example 17b. Okay, Fs, capital Fs is equal to 1 over S power of 5. Okay, so I jot down the question. Okay, B, capital Fs equal to 1 over S power of 5. Right, so we go to Laplace table. Okay, from this formula. So we find which is S power of 5, something like that. So you can see this is the answer. Okay, S n plus 1. So the question for B is 1 over S 5, meaning that 1 over S 4 plus 1. So n is 4 here. Okay, so from the table we know that Fs is equal to n factorial divided by S n plus 1. So Laplace inverse n factorial divided by S n plus 1 is equal to t power of n. Okay, so for this question n is 4. Okay, from here 4 plus 1 you get 5. Okay, so n plus 1. So Laplace inverse 1 over S power of 5 is equal to Laplace inverse. So we have to do n is 4. So 4 factorial here divided by S 4 plus 1. So the original one is 1 here. So 1 over 4 factorial. So equal to, so you factor 1 over 4 factorial. So 1 over 4 factorial Laplace inverse 4 factorial as 4 plus 1. Okay, so this one is 1 over 4 factorial Laplace inverse 4. We know that this one is t power of 4. And then use calculator. 4 factorial is equal to 24. Or we can say that 4 times 3 times 2 times 1 is equal to 24. Okay, so we get the answer t power of 4 divided by 24. Okay, now we look at example 17c. Okay, Fs equal to 6 over S minus 1, 4. Okay, now look at C. Fs equal to 6 over S minus 1, 4. So this one Fs equal to n factorial Sn plus 1. So Laplace inverse 6 divided by s minus 1 power of 4 is equal to, so we know that this one is s minus 1, okay, but this one is s, so this one is f s minus a. Then we know that for f s minus a is e a t times ft. This one is first shifting property. So a is equal to 1. And then we have to get what is ft. So ft is come from fs. So fs is 6 divided by s4. So we change the property from 6 divided by s minus 1 power of 4. So Laplace 6 divided by s power of 4 is equal to Laplace. So n is 3. So 3 factorial divided by s 3 plus 1. So this one is 6 divided by 3 factorial. Then 6 divided by 3 factorial, Laplace inverse 3 factorial as 3 plus 1. So we get t power of 3. So Laplace inverse 6 divided by s minus 1 4 is equal to e. A is 1, so e power of t times t power of 3. Okay class, I want you to try to answer this question. Okay, A and B. The hint is Laplace inverse f s minus a. Okay, this one also same. Laplace inverse f s minus a. So, can you try this question A and B? And you can choose the answer given in the video. Okay, you can try it.